Hello everyone and welcome back to RNN Lab GH. Today I want to present a project that is not only interesting but also extremely useful for your lab, for your Arduino projects, or simply for anyone who is taking their first steps into electronics. This project requires very few components because most of the work is handled by the code that I will provide you. What will we use for this project? To build our component tester, we will need the following materials. Our trusted Arduino Uno, the monster of all projects. A breadboard and the jumper wires. 3 resistors with a value of 470 kiloohms. 3 resistors with a value of 680 ohms. 1 resistor with a value of 10 kiloohms. 1 push button. 2 3-pin connectors or terminals. 3 pieces of wire and 3 alligator clips for connecting the components we want to test. The LCD display 16:2 with the integrated I2C interface to simplify the wiring. As always, I have prepared a very simple and intuitive assembly diagram for connecting the components to the board, which you can find in the link in the description. By following the diagram and watching the video, the assembly will be extremely easy. One important piece of advice: carefully check the value and the respective pin number for the 6 resistors, the 470 kiloohm and the 680 ohm ones. Other than that, it is a very simple and rewarding project. Now that we have reached the end of the component assembly, all that remains is to move to the computer and prepare to upload the code. As always, let's connect the Arduino to the USB port and open the code, which you will find in the description link, titled Tester Component. A note on the code. I want to point out that this code is quite complex and very long. It contains a massive 4,819 lines. All this complexity is necessary to accurately manage all the different measurements and the relative classifications that we collect from the components. What I recommend, so that everything works perfectly, is to pay extreme attention during the code upload. If you inadvertently modify even a single part, the tester will not function correctly, and the measurements taken will no longer be accurate, or the circuit may not even start up. For any problems that might occur, simply download the code again from the link in the description, so you always have the correct and original version. Another piece of advice for the more experienced users, I invite you to examine and verify the code structure. The way it has been structured and how the calculations are performed to detect and classify the different components by category and family is very interesting. After uploading the code, always remember to select the correct board and the right USB port in the Arduino IDE. Now, we will go ahead and verify the operation and see exactly how our tester works. Now let's test our component tester in action. Before we begin, I want to point out that this tool can easily run on a 9-volt battery, making it perfectly portable. Component testing. First, let's test some electrolytic capacitors and a ceramic capacitor. You will see that the tester automatically recognizes the component type, providing the capacitance value and the important ESR parameter, which stands for equivalent series resistance. You can use either the allocator clips or the dedicated pin sockets on the breadboard. It makes no difference where you place the component leads, the tester automatically recognizes the polarity and the position between the 3 pins, indicating the correct pin at. Now, let's test some resistors. As you will notice, the tester immediately recognizes the component and displays its value. This is extremely effective for getting fast and accurate results. Let's move on to the diodes testing a normal diode and a Zener diode. Observe the simplicity of recognition and the speed of the voltage drop reading. It is time to test a transistor. As you can see, the tester not only tells you whether it is a PNP or NPN type, but also provides the gain values HFE and the precise position of the lead, base, collector, and emitter, making it very simple and fast. Now let's test a photoresistor, also known as an LCR. You will see that its value changes based on the ambient light. You can test the LCR's efficiency and calculate the resistance value based on a light, which is essential data for integrating it correctly into your next project. Next, we test some LEDs. The tester makes the LED flash to confirm it is working and provides you with the operating voltage value. You will notice that the working voltage changes based on the color of the LED. This is also very interesting for your projects, as it helps you calculate the necessary current limiting resistor to prevent damaging the LED. Finally, we test an inductor, for which the tester will provide the value in millihenry. Conclusion. So, you have seen the use of this project. It is extremely interesting and useful. Right now, it is mounted on the breadboard, but by using a simple perf board and a few wires, we can create a genuine laboratory instrument, robust and portable, powered by a single 9-volt battery. Thank you all for watching this video. I sincerely hope this project was useful to you and that it inspired you to build your own component tester. If you enjoyed the video and found it instructive, subscribe to the channel, leave a like, and activate the notification bell to be updated on the next video. Leave a comment below for any feedback or questions. I always respond to both comments and emails. Thank you all again for your support, and I wish you a great end of the year and a happy start to 2026. I promise nothing, but if all goes well, there will be a final special video for 2025 coming out on December 31st. There will also be big news arriving for 2026. I am working hard for you. See you next time.